Hi, this lesson is to take you through the presentation on box and whisker plots. This is the actual lesson presentation that we'll be doing in class. I'll do the lesson live, and then this video is to supplement for any students that are not in class or who need to go over the material again because you missed writing something down. In addition, there's a video that I made last year which goes over the mechanics of making the box and whisker plots. So this is it's what we call box and whisker plots. They're also simply called box plots sometimes. So sometimes the directions will just say, look at the box plot. If you have a TI 83 or 84 graphing calculator, they will do these for you as well once you start learning how to use some of the statistics features in them. This lesson is just going to go over how to make them and what they show us. So why are we interested in making this particular kind of graph and what information do we get out of it? So there are two main categories of statistics. That's a gross oversimplification of what stats is, but you can think of like two main categories of numbers that we think about. One is the measure of the center of numbers. So you got all this data, you have all these numbers. Where is the center? So we got some examples here, which I think you're familiar with. One is the mean, also called the average. There's actually more than one kind of average. And if you study geometry, you've probably learned about something called the geometric mean. And so we do kind of overlap with those words a little bit, but typically the mean is what we're referring to is the arithmetic mean, which is the average. Now, the word average can also be used to describe the other data points here, so you want to be a little bit careful, but usually average and mean are the same thing. The median, which is defined as the middle number, so I'll go ahead and write that in. I don't know if it'll let me do it with my hand. Oh, it will. There we go. The middle number in the data set. When the numbers are listed in order from least to greatest or greatest to least, I would encourage least to greatest. And then something called the mid-range. Now you might be saying, oh, well, what about mode? Like it's always mean, median, mode, mean, median, mode. Mode is also a measure of central tendency, but there's nothing about the definition of mode that means it actually needs to be in the center. So the mode is the most commonly occurring number, which could actually be like the lowest number in a data set or the highest number. So I left it off this list. The mid-range is basically the average of the highest and the lowest. So if you didn't want to look at all of the numbers, if you just took the lowest number that you had and the highest number that you had and you average them together, my hands weren't on the screen there, and you average them together, that number is the mid-range, which is really useful for things like the average daily temperature. So they'll take the high temperature during the day and the low temperature at night and so forth. Then there's measures of spread, and these are numbers that describe how stretched out the numbers are. So some examples of this are the range. That's a data value that you're probably familiar with from middle school, where you take the highest number and the lowest number and you subtract them. And it just tells you the distance between the highest and the lowest number. So what is the spread there? Variance, which is something that you would study in a college level class. And then standard deviation, which we will do in this class. And you do cover that in Algebra 2. And then, of course, if you take a prop stat class or something, you'll talk about standard deviation. And that's kind of, this isn't the definition, so don't quote me, but it gets the concept about as clear as I can get the concept. Standard deviation is like the average distance from the average. So if you were to average everything together and get the average number in the middle, and then you measure how far away each data point is, and then you took those distances and averaged them together. We will not do that in this lesson. So those are the two main categories. We care about these two measures because one of them tells us where the middle of the numbers is, and that's often what you're interested in terms of your grades. Like the grade you get on your report card isn't the highest grade of anything that you got on any assignment all quarter, but it's also not the lowest thing that you might have gotten on an assignment all quarter. It's somewhere in the middle, so you're interested in that. The other tells us how spread out the numbers are. So you could have an 80 average in this class because every single grade you got was an 80. I'll let you think about that for a moment. Like every single grade was an 80. then your average would be an 80. 80 plus 80 plus 80 plus 80 plus 80 plus 80 divided by however many 80s you have is going to give you an average of 80. And it would be very, very close together. All your numbers would actually be like right on that one point. Now, you know, most of the time that doesn't happen. Most of the time your numbers are kind of spread out. So maybe your grades are between like a 75 and an 85, and they could average together, you know, as an 80. Or maybe your grades are like 60 and 100, and they're really spread out, but they still average out to that 80. And so the measures of spread tell us like how much the numbers are spread out, or are they all close together? And together they paint a fuller picture of the data. Just knowing where the middle is or just knowing how spread out the numbers are doesn't tell you everything that we need to know about those numbers. So a box and whisker plot gives us a way to actually draw a figure that shows us both the middle, the center of the numbers, and the spread of the numbers. So we'll get a sense of both of those statistics in this one picture. And you know that like pictures are often easier to deal with than lists of numbers. So some examples of box and whisker plots, that would be like 3 of them that are done on one graph and probably with the intent to compare. I've seen a lot of these recently because, you know, we're still going through COVID and stuff, and they'll do like measures of the virus, and they'll do like unvaccinated people who have never had COVID, vaccinated people, and then people who have had COVID. And they'll like kind of compare to like see what the difference is, you know, are people behaving differently or getting the virus differently depending on what their status is. And they might take all 3 of those categories and put them on one graph so you can compare them and look at how they're the same or how they're different. This is one, again, where you've got like the 2 graphs on one, and that was actual weights of university students, is what it says there. And there's tons of stuff where you can do things like this. And then the last one I had on here, sometimes you'll see them vertically, but it's the same kind of graph. And take a moment and look at this one right here. If you can see where I'm pointing, you'll notice that one looks a little different. There's no whisker part, or there's no little branch down at the bottom. And we'll deal with that in this lesson, like how that happens and that it can happen. Note the box in the center with the 2 whiskers out to each side. So that's where this kind of graph gets its name from. You got like the box in the middle. Here, I'll like, there we go. You got like a box in the middle, and then you have whiskers that go out to each end. So once you know where to like draw your box and where to draw your whiskers, like you should be good to go for doing box and whisker plots. So to make one, I just inhaled that. To make one, we need 5 key numbers. So I've heard these things, like I call them 5 key numbers, but I've heard like key number summary. Like there's different words that people use to describe this particular collection of numbers. So use your common sense if you're taking like a major exam and it sounds like they're probably talking about these numbers, but you're not sure. They use a slightly different verbiage. Probably they're talking about these numbers. So to do this, you need the minimum number. Okay, and you'll notice on this is actually a really useful diagram right here. You've got the minimum number is down here. They have it labeled on the left-hand side, and then they have the whisker labeled. Then something called the first quartile, or Q1. This particular diagram calls it the lower quartile, and notice where it's labeled on that diagram. Then we have the median, which I'm assuming that you've studied somewhere. We'll go over how to find it, but the median is the middle number, and I'm just assuming that you know how to find it. And the median is written over that line there. Then we have the third quartile. Oh, and the median is also called the second quartile. You must never hear that, but a lot of times students will wonder, why are we jumping from first quartile to third quartile? Like what happened to the second quartile? Second quartile is the median, even though we don't usually call it that. The third quartile, and you'll notice here on this diagram, it's labeled as the upper quartile. And then we have the maximum number, which is way down here on the right. And then this diagram like labels both of the whiskers, and then they label the box, you know, like, in case you couldn't tell That's the box. And then they have in purple here something called the interquartile range. And if you, or IQR. So if you're taking notes, you probably want to write that down. Like IQR, what is that? If you think about this, even though some of the vocab is new here, quartiles, you've got like this first quartile and this third quartile, and they're labeled on the diagrams here. Inter usually means like between or among. So like an inter-office memo is a memo in the office. And so if you think of inter as being between, and then quartile, it's between the quartiles. Now we haven't talked about what the quartiles are, but like hopefully the word kind of comes together and makes sense. So inter, between quartiles. And then range, we know, is the difference from the highest to the lowest, or it's like a measure of how wide it is. So interquartile range is like how wide is that box. And if you know like your prefixes and you're able to piece together the vocabulary, sometimes even if I don't teach you the vocabulary, you could probably figure it out. So how do we go about doing this? So now we know what box and whisker plot can tell us, and we know what it looks like, and these 5 key numbers. How do we actually go about doing it? So this procedure, I'll work through this fairly slowly, but this is a recorded video, and I believe I'll post the PowerPoint in the unit files, so you can access that if you need to go back and look at it. So I'm not going to slow down too much here for you to write stuff down. I know you can pause the video if you need to. You want to list the numbers from lowest to highest. It could be from highest to lowest, but when you're reading a number line, it always goes from lowest to highest. So be consistent with that. Like why do it differently? Like why do it differently? So list the numbers from lowest to highest. The lowest number is the minimum. I hope that's obvious. Lowest number that you have is the minimum. This marks the end of the left whisker. So you're going to have like your box and whisker plot. And the number out there at the end of that left-hand whisker is the minimum. And this should match the diagram that I had up there before. The highest number is the maximum, and that's going to mark the right-hand side of your box and whisker plot. And the middle number is the median. This is why you really have to have them listed in numerical order. The middle number is the median, and that's the line in the middle of the box. Now, I want to be careful. When I say the middle of the box, when I say middle, I don't mean center. Like it's not like in the exact center. Like sometimes the median, like the line could be off to the side, but it's like in the midst of the box. It's like inside the box somewhere. If there are 2 middle numbers, so we know the middle number is the median. If there are 2 middle numbers, then you're going to take those 2 middle numbers and average them together. So we'll actually see an example of that when we do ours. So, all right, next you're going to split the list in half, okay, which is convenient that you've just found the median, which is the middle number, because if you're going to split it in half, that's the place where you're going to split it. Okay, good animation there. If there are an even number of items in it, so you actually have an even number of data values, you just split it right down the middle. So you have your lower half and your upper half. If there's an odd number of items, you can't split it right down the middle because you've got this like middle number in there, and you like, where does that middle number go? Does that middle number go with the bottom half or the top half? And the answer to that is neither. You just throw out the middle number and then you just take whatever's left over. Never throw out more than one number. So a common misconception that students will have sometimes is when they have 2 middle numbers, they're like, oh, I have to throw a number out, and they'll throw them both out. You don't want to do that. So you want to include as many data values as possible. You don't just like throw stuff out of your data set. The only reason we throw this one out is because we can't put it into one of the halves. So you should never be throwing out more than one number. Find the median of the lower half. Now we already went over how to find the median. Okay, that's the middle number. So you're going to look at the lower half of the numbers, and then you'll find the median. So you split the bottom half, find the middle of the bottom half. That is Q1, and it marks the left end of the box. So I'm wondering, where do I draw that box? Well, this will be the middle of the bottom half. Find the median of the upper half. Probably not a surprise. Probably not a surprise there that you find the median of the upper half. And that is, oh man, I am swallowing really bad. Sorry about that, guys. Now I'm going to start tearing up. And that'll be the upper end of the box. So that is your third quartile. And that's all you really need to construct your box and whisker plot. You need to know where the lower whisker ends, the upper whisker ends, and then the middle, like, or the line in the box, and then like the actual beginning and end of the box. Essentially, we are dividing the data into 4 sections, hence the word quartiles. If you're wondering, well, where did the word quartile come from? If you think quarter, 1/4, divide something, quarter it, means to divide it into fourths. So we've got this list of numbers, and then we split it in half, and then we split each half in half. And so now we've got these like 4 sections of numbers. And these are just the rules for how you would split that up. So we're going to do an example here. I'm going to try to write with the mouse on this computer. I have a nice stylus, but I think it's at home to write on the touch screen here. So just kind of do the best I can. I might write with my fingers. So if I'm kind of gawking over the screen there, that's what I'm doing. So we have some data, 4, 5, 5.5, 3, 7, 3.1, 5, 8, 20, and 6. Okay, so the first step we need to do is we need to write that in numerical order. Please do not try to do that in your head. And this is often like the worst part of it, is especially if you have a lot of data values, is trying to sort through them. So our smallest number is a 3. And then we have a 3.1. Now what I'm going to do as I'm doing this is I'm actually going to cross them off the list, because one of the easiest mistakes to make is to leave something out during that rewrite step. Then we have 4, then we have 2 5s, and then we have a 5.5. All right, so 2 5s, and then the 5.5. Then I have a 6, a 7, and 8. And we'll go and cross those off, 6, 7, 8. And then I have this 20, which really doesn't seem to fit, but it's in our list. So write the numbers in order, and then find the minimum, the maximum, and the median. So that comes really fast after, and I have no idea why I did it that way. I don't want to do that. Okay, let's start with the minimum. Let's try again. Let's go. Minimum. Once you do this, the minimum is obviously a 3. The maximum, I'll put the max down here at the bottom of my list. The maximum is a 20. And the median is going to be the middle number. So when I go to count these, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, I actually have 2 middle numbers there. Oh, wait a minute. Oh, gosh. I'm very, very tired this morning. So there you have that going. And also have notifications. So the 2 middle numbers are 5 and 5.5, and you can't list 2 medians. So what we need to find is we need to find the middle, like between the 2 middle numbers, and that would be 5.25. And so obviously decimals are totally fine to have here. And I'm going to go ahead and erase that. Next step is to split the numbers in half. Well, there are 10 numbers in this list, so I can split them right down the middle. I have 1, 2, 3, 4, 5 numbers on the left, and 1, 2, 3, 4, 5 numbers on the right. So I can split them straight down the middle. You don't throw anything out in that situation at all. And if you did have a middle number, you would just like throw out that like one middle number and you'd split the rest. Now we're going to find the median of each half. So now I've got this bottom half of the numbers, and I'm going to find the middle of the bottom half, which is 4. So my first quartile is 4, and then I'm going to do the same thing with the top half, and my third quartile is 7. And the same rules apply to this as before. So if you're looking for the median of the bottom half and you have 2 middle numbers, you would average them together. Okay, if you have 2 middle numbers of the top half, you would do the same. And now what we've done is we've essentially divided the data into fourths. So we've got like this fourth, this is like rough, and this, and the 4 and the 7, like they don't quite fit, but they're marking off the halfway point, and then that 5.25 is like marking off the middle. Okay, so you go find your 5 key numbers. To make the plot itself, draw a number line that covers the entire range. So by that, you mean that your number line has to go at least from the smallest number in your data set to the biggest number in your data set. It is a regular number line. I want to be clear what I mean by that, because I see this mistake so often and I try to be really, really clear about it, okay? If I were to ask anyone in the class to do a number line, you would do something like this, all right? Yay? No one in the class would do a number line that looked like this. At least I truly hope not. Okay, so right off the bat, I hope you notice like a number line doesn't have 2 5s on it. It doesn't. You guys have seen plenty of number lines enough to know that there are not 2 5s on a number line. Also, if your number line is counting by integers, so it's going like 3, 4, 5, 6, then 6.5 should not have its own tick mark. 6.5 would be somewhere between the 6 and the 7. So this is, no, do not do that. It's actually a really common mistake. Students will just list the numbers as though the numbers were the number line there, and that's not how that works. So you're just going to draw a regular old number line. It's going to have numbers on it that aren't in your data set, and that's fine. Place a dot above the number line at each key number. If you go back and look at the examples from the earlier slide, you'll notice that the number line was down at the bottom and the box and whisker plot was above it. Like you don't put the box and whisker plot on top of the number line. So you're going to place a dot above the number line at each key number and then draw in the whiskers and the box. So once you have those points marked, then you know where your whiskers are, you know what your box is, you know where your middle line should be. So for our example, we had data ranging from 3 all the way up to 20. So I'm going to start my number line. I'm going to start it at 2 just to give myself a little bit of space. 4, 5, 6. And what I did was I just paused the video so I could fill it in because you guys didn't need to see me do all those numbers in. Now I made my number line go from 2 to 21 just to kind of go a little bit above where my box and whisker plot is. You don't have to do that. I just like to do it because I don't like the feeling of the thing being cramped. Notice that it's a regular number line. So even though there were no 15 and 16 in my data set, like they're still on the number line because I have to make my number line go up to 20, which means I have to cover the numbers in between. Now you can count by halves, you can count by fourths, like you can count by tens on your number line. You just want to scale it appropriate for whatever your data values are. Next step is to place a dot above each key number. So remember our minimum was 3, so I'm going to put a dot above the 3. The first quartile was 4, so I'm going to put a dot above the 4. The median was 5.25. Now 5.25 isn't on my number line, so I do have to estimate where that is, and that's totally fine. Then my third quartile was 7, and my maximum is way out here at 20. And now we're going to draw in the whiskers and the box. So remember that the first line there and the third segment, fourth segment out there, those are the whiskers. The second and the third mark the box, and then we have the line in the box. Now, a couple of things to notice about this, like why this is useful. Notice that the line is not in the exact center of the box. It's pretty close, but it's not. And so your line, it represents where the median is, All right, it doesn't tell you, like, it doesn't have to be like smack dab in the center of the box. Also, what's blazingly obvious here is that the right hand whisker is a lot longer than the left hand whisker. And what that probably means is that you have something called outliers. You have like some number or numbers, it could be like a few of them, that don't fit with the rest of the data points, and so they're causing that whisker to be really long, and you can actually see it. And then this is what's called the interquartile range right here. So my interquartile range is from 4 to 7, and this is the middle half of your data, which is kind of a weird thing to think about. You usually think of the bottom half and the top half. I'm in the top half. But what this does is it like pulls off a quarter on one side, a quarter on the other side, and then you have the middle half with the data out on the ends. And so it's actually very valuable because it tells us that half of our data is clustered in that box there. All right. So sometimes some weird stuff can happen. So I want to address this before I move on. So sometimes this weird stuff can happen. We'll do a number line down here that goes from 2 to 8. So we have 2, 3, 4, 5, 6, 7, and 8. So on this first one, I mark my minimum, and then what you'll notice is that my first quartile is actually the same number as my minimum. So I can't put another dot there. I mean, I could, but I won't be able to see it. Then we have the 3, the 4, and the 6. And so this is a whisker, but this ends up being the box here. And that's because your minimum and your first quartile are the same, and you end up not having this whisker. So I don't want you to think that that's wrong or that you've done something wrong if that happens. Yeah, like there's nothing wrong with it. It just can happen. It looks weird. The other weird thing is this one over here, where you can have your minimum, your first quartile, and then your median is the same as your first quartile. And then we have the 7 and the 8. So we draw a line from the minimum to the first quartile, and here's the third quartile to the end. But now there's like no spot to put the line in the box because it duplicated with the left hand over there. So yeah, so that can happen as well. It doesn't happen too much, and where you guys are going to be working with data sets of 10 like numbers, it might. So I just wanted you to see that so that you weren't, you didn't think you had done something wrong. So what you need to do is you are going to take your data from your beanbag launcher, and you are going to create a box and whisker plot for your launch data. You're going to turn on a separate piece of paper. So I should see like your actual data. So I should see your data table with your data in it. I should see your 5 key numbers. So clearly labeled, like my minimum, my first quartile, my median, third quartile, and my maximum. And then I should see your number line with your dots and your box and whisker plot on it. So that is your task for this particular assignment, and I hope that this video helps.